Okay, let's pump the brakes on the hype-mobile for a sec. There are some absolutely amazing things that Microsoft accomplished with this new chip, specifically creating a new kind of matter. I mean, wow. But there's quite a fair helping of BS and half-truths in this PR bonanza as well. So let's break it down really quick. What it all really means and how this new Majorana 1 chip compares to Google's Willow quantum chip released back in December of 2024. Both companies have made bold claims about their quantum computing breakthroughs, but let's cut through the PR to understand what's really happening in this quantum race. Microsoft's announcement is genuinely exciting from a pure physics perspective. They've managed to detect and create Majorana particles, exotic quantum entities that are their own antiparticles. The creation of a topological material, not a solid, liquid, or gas, but a completely new topological state, is a profound scientific achievement that would make physicists like Peter Higgs proud. This is fundamental physics research bearing fruit. However, we need to separate the scientific breakthrough from the quantum computing reality. Microsoft's press release video repeatedly mentions 1 million qubits on a single chip, creating the impression they built something revolutionary in scale. Yet, buried in the written announcement is the critical detail that so far, they've only placed 8 topological qubits on a single chip, after 17 years of research. So, now, to be fair, Microsoft's approach is fundamentally different. Their topological qubits are potentially more stable and error-resistant by design, which could eventually lead to more reliable quantum computers. But the key word is eventually. They're showcasing the foundation, not the skyscraper. And it could be a very long time until we see the skyscraper. Now, contrast this with Google's Willow chip, announced months ago in December 2024. Willow already features 105 qubits, over 13 times more than Microsoft's current implementation. More importantly, Google has already demonstrated 2 critical achievements. Number 1, their exponential reduction in error rates as they scale up qubits, essentially cracking a 30-year quantum error correction challenge. And 2, performing calculations that would take today's fastest supercomputers an absurd 10 septillion years. That's a 1 with 25 zeros after it. Google's approach focuses on practical error correction implementation rather than starting with error-resistant qubits. They've shown that as they scale from 3x3 to 5x5 to 7x7 qubit grids, they cut error rates in half each time, what they call getting below threshold, which is essential for practical quantum computing. Both Microsoft and Google make grand claims about quantum computing's potential to revolutionize drug discovery, materials science, climate change solutions, breaking down microplastics, and creating self-healing materials. These applications are genuinely exciting, but here's what's missing from both announcements. Many of these breakthroughs aren't purely dependent on quantum computing. Take protein folding, for example. Google's DeepMind's AlphaFold made incredible progress in 2024, solving structures for nearly all known proteins. This was accomplished using traditional computing architecture combined with advanced AI. Quantum computing will likely accelerate these discoveries, but the fundamental breakthroughs in AI are happening independently. Quantum computers are tools that will enhance AI capabilities, not replace them. What's curious about Microsoft's announcement is the complete absence of any comparison to Google's Willow chip. They position Majorana 1 as if it exists in isolation, despite Google having publicly demonstrated substantial quantum advantage just months prior. This isn't to diminish Microsoft's scientific achievement. Creating Majorana particles and topological qubits is groundbreaking physics. But from a practical quantum computing perspective, they're playing catch-up while positioning themselves as pioneers. Let's be honest about timelines. Microsoft's path to a 1 million qubit topological quantum computer will take years, possibly a decade or more. Google's Willow is already demonstrating quantum advantage, but practical, commercial applications are still years away. Both approaches face enormous engineering challenges to scale reliably. Microsoft needs to increase their qubit count by multiple orders of magnitude. Google needs to continue improving their error correction while maintaining performance. One thing is for sure, the quantum computing race is accelerating, with Google currently leading in practical demonstrations, while Microsoft pursues a potentially more stable foundation with their topological approach. The real excitement should be about the combination of quantum computing with AI systems like AlphaFold. Together, they promise to unlock solutions to humanity's greatest challenges in medicine, materials, and environmental science. So, what are your thoughts on these quantum developments? Do you think Microsoft's approach will eventually overtake Google's? Let me know in the comments below, and don't forget to subscribe for more tech analysis.